Okay, the other day when we were learning Maclaurin polynomials and Taylor polynomials for the first time, we had, there were four curves. There were four curves that had little shortcuts for them, for the Maclaurin series that we could, well, not shortcuts, but we knew that it was going to be the same polynomial every time, so we could just use it. And one of them was for 1 over 1 minus x, and it looked for the sum of a geometric series. So if you guys remember, the polynomial for this one was that it was approximately 1 plus x squared plus x to the third plus x to the fourth plus x to the n.
Nice.
Yeah.
Can I get one of those sheets? Come on, dog.
I think they're
I want to use this.
maybe over there.
Come on, dog. Is it over here?
In the second from the bottom, if they're not there, I don't have any more. All right, so if you look at this, this is kind of mimicking the sum formula, that the sum is the first term divided by 1 minus r. That's what this is mimicking. So a is the first term, and that's 1. And r is the common ratio. It's what you're multiplying by every time, and that's x. And it's going to converge when the r is less than 1, and it diverges when the r is greater than or equal to 1. So we call these geometric power series. Geometric and power is kind of redundant because when something's geometric, you have something in parentheses right to the power of n. So it's kind of redundant. So like this one, the original that we use for this, we'd say is n is 0 to infinity, and it would be 1 times x to the nth. That's like the very basic version of it. And we're just going to look at some where they've got other numbers in there. So when you do the interval of convergence, you do not have to check the endpoints, because every single time if you were to plug that number in, it would always give you a ratio of 1. It would give you an r value of 1. And what happens if your r value is 1 exactly? It diverges. So we know that whenever we do our interval of convergence, we're always going to have parentheses for these every single time. And we don't ever have to test it because we know it's always going to work out the same. And we're going to be lazy about it, right? So for this one, we know that it converges when the r value is less than 1. So the interval is from -1 to +1, and I don't have to check the ends. I can just say those are parentheses. Okay. All right. So for this first example, you're going to have to write pretty small to fit it in this space because I did not retype these notes from the other teacher. So you can write real small. You can do it on a separate sheet if you want. It's kind of up to you. But what we want to do is we want to rewrite this problem so that it fits this formula right here. So that it fits, the first term is on the top and then the bottom is 1 minus r. So what I'm going to do with this is I'm going to go ahead and rewrite it so that the x comes second, because that's where the r is. So I'm going to say this is the same as 4 over 2 plus x. And then I know the bottom has to be 1 minus r. And so I'm going to pull out the 2. So if I pull out the 2, the second term wouldn't be an x anymore. What would it be? It'd be 1/2, right? So if you take an x and you divide it by 2, you get x over 2. So if I keep going with that, then I can say that this is the same as 4 on the top and then 2 on the bottom. And then 1 minus -x over 2. So now I can see that this right here is my a, or my first term. And that this right here is the r value. And I can tell that's what they are because now they match up that formula that the sum equals a divided by 1 minus r. All right, so I'm going to write this as my sum. I'm going to say the sum from n is 0 to infinity. And then I write the first term, and what's the first term? 2. 4 divided by 2 is just 2, so first term is 2. And then what's my r value? Negative x over 2 to the nth power. So there's my series right there. Now, whenever I write this with that summation notation, since I just put an exponent of n, then I have to say that n starts at 0. That's how it makes my first term 2. If you wanted to start at 1, then your exponent should be n minus 1. Alright, so on my answer keys, I always do n and 0. And that's how I knew that it was supposed to be a 0 there, is I'm making sure that if I plug in 0, I really do get 2 as my first term. Okay, that makes sense? Okay. Now we want to find our interval of convergence. So I'm going to say, I know that it converges if the r is less than 1. So I'm going to say, if negative x over 2 is less than 1, then it converges. And then what do I do? Multiply by 2. So the absolute value of x, or negative x, I don't really care how you write it since it's absolute value anyway. So the absolute value of x is less than 2. And so that means that our interval of convergence for this one is negative 2 to 2. Again, definitely parentheses, because if we were to check the ends, they would diverge every time. Okay, so for the second one, we have to think about what needs to happen to it so it looks in the right form. So the 3 on the top is okay. What should we do on the bottom? Take out 5, good. So that'd be 1 minus, 1/5 x, or you could write it as x over 5, it's up to you. So we divided the 5 out and we moved it to the front. So that means that this is our a value, and the bottom is written as 1 minus r, and so this right here is the r value. So what should I write? Okay. So there's my series. And then if I want to find my interval of convergence, I'm just going to say that the r value has to be less than 1. So x over 5 has to be less than 1. And then what do I do? Multiply by 5, so x is less than 5. So the interval of convergence is negative 5 to 5. So as long as you plug in x values that are between negative 5 and positive 5, then that series will converge. Yeah.
Oh, it wasn't have parentheses?
So if you're always going to have parentheses, because if I was to plug in negative 5 exactly, then I would have an r value of negative 1, and that's going to diverge.
Okay.
If I plug in positive 5 exactly, then I'm going to have an r value of 1, I'm going to diverge. And that's always going to be the case. The endpoints are always going to diverge for that specific reason. So that's why we don't check them every time. Yeah.
So maybe I'm missing, but how do I know that the midpoint is 0?
Because, and it's always going to be 0. We're going to set it up so it's always like that, but we know that the middle is 0 because it'd be x minus 5 minus x over 5 minus 0 in the parentheses. Yeah. And since we are always setting these up as a geometric series, they're always going to look like that. They're always going to be centered at 0. Yeah. All right, next one. So this one's ready to go. What's the a value here? A is 1. What's the r? 2x. Okay, so we can just automatically go into writing the power series. So we've got our first term times the r value to the nth power and that's our whole series right there. And then we can go ahead and find the interval of convergence. So if I have 2x is less than 1, what should I do? Divide by 2. So x is less than 1/2, and then that makes our interval -1/2 to +1/2. Next one? Okay. All right, for the next one, you're going to need some more paper. Sorry, get out some paper. There's no way you can fit it in that small space.
What if I do?
Then your notes may not be as effective when you look at them in the future because it'll be too small. We're going to go back to those warm-up problems, actually. Okay. So, what do you guys think is wrong with example 4? Like, why am I making you get out paper? What's the rough part of it? Yeah, there's an x on the top. You guys see that?
Yeah.
So the fact that there's an x on the top is what ruins this problem for us, because we're supposed to have an a value on the top, so that we've got a first term, and then the x value is always supposed to go as our r value. So can anyone think about what we possibly might be doing with this?
Erasing.
We've done it before, you just might not ever think to do it in this circumstance. We're going to do partial fractions. We're going to split it apart. We're going to split it apart into two different fractions, and then we're going to deal with the two different fractions separately as like they're two different series. Right? So, to do that, we have to factor the bottom, right? So, how do you factor x squared minus 1? Okay, so we got 3x minus 1 over x plus 1, x minus 1, okay? And so I'm going to say that this is a over x plus 1 plus b over x minus 1. And then what should I do next? Yeah, so I'm going to multiply by x plus 1 times x minus 1. A times x minus 1 plus b times x plus 1. Okay. And then how do we figure out what the a and the b are? Plug in some numbers. So what number should we plug in for x first?
1.
Okay, if x equals 1, then 3 times 1 is 3. If we plug in 1 here, we get 0. If we plug in 1 there, we get 2. So we get 2 equals 2b, and then b equals 1. Okay. And then what should I plug in next? So 3 times negative 1 is negative 3. A times negative 2. B times 0. A equals 2. Okay. So instead of our original function being f of x equals 3x minus 1 over x squared minus 1, we're going to say that our original function was actually 2 over x plus 1 plus 1 over x minus 1. And now we're ready to do it. We're just going to have two different series. Does that make sense? Okay. So now I can fix the first one. So that is going to be 2 over 1 plus x. And then that's going to be 2 over 1 minus x. So what's my a value? What's the r value? And then we can do the other one. That's going to be 1 over negative 1 plus x. And then, Ms. Adams. And then for this, we can go ahead and factor out a negative 1. And what happens when we factor out a negative 1? Minus x. Okay, so what's our a value? Negative 1. And then what's the r value? X. Okay, so when we write out our series, we're going to say the first term times the r to the n plus the first term times the r to the n. So when we wrote out our series this time, we just had to add two different things together. Does it make sense how we thought about that? Sure. So the one I just did, that's like the tricky one. That's the tricky version.
That's as hard as it gets, right?
That's like, they could be maybe a little bit harder to do to figure out like your A and your B on, maybe, or maybe not so nice to factor. This assignment is a lot easier than what you guys did today. Okay. So now we do have to find the interval of convergence. But the lucky thing for us is that these intervals of convergence are the same. Do you guys see how they're the same? So it's negative x is less than 1 or positive x is less than 1. And either way, yeah, what's our convergence? Negative 1 to 1. Okay. What I want you to do for homework in regards to this is I want you to do the 1 through 3 warm-up problems. I want you to think about number 4, but I don't want your head to explode if you get confused on it. So 1 through 3, and then I'm going to make a video for 5 through 8. Okay? The other examples. Yeah.
So, if those two were different, what if they were two different?
If they were two different, and we'll look at one of the other examples we'll go over, we'll show different ones, then you take the interval that's more conservative. So like if you have one interval that's negative 100 to positive 100, and the other interval is negative 5 to 5, then you're going to take negative 5 to 5. The smaller interval. Yeah. Homework is to do 1 through 3 of the warm-up, and then a video to do the backside of it.
Are you trying to go to Lakelands with me?
Maybe sometimes.